Hello students, today we are going to be learning about three-dimensional objects. Three-dimensional objects are polyhedrons. Now, three-dimensional objects or polyhedrons are ones which we can actually see, touch and feel. They are not just 2D flat objects like the polygons we have been learning before. Polyhedrons. A three-dimensional shape whose faces are polygons is known as a polyhedron. It is derived from the Greek word poly, which means many, and hedron, which means faces. So polyhedron is a three-dimensional object with many faces. For example, now let us consider a cube. It has 6 faces. 1, 2, 3, 4, 5 and 6, all of which are squares. Next, let us take up the cuboid, which is again having 6 faces. 1, 2, 3, 4, 5 and 6, in which some of them are rectangles and some of them are squares. Let us now try to understand the meaning of faces, edges and vertices of a polyhedron. Faces. The polygonal region of any solid is called its face. For example, we have already seen a cube which has 6 faces, namely 1, 2, 3, 4, 5 and 6. Now look at this solid which is having 5 faces. 1, 2, 3 and 4 triangular faces and 1 square face. Moving on, vertices. These are points at which 3 or more faces meet. For example, coming back to the cube, it has 8 vertices. 1, 2, 3, 4, 5, 6, 7 and 8. In case of the second solid, it has 5 vertices, 1 at the top and 2, 3, 4 and 5 at the bottom. Moving on to the edges. Edges are the line segments along which 2 faces intersect. Again, for a cube, it has 12 edges. 1, 2, 3, 4 on the top, 5, 6, 7 and 8 at the bottom, 9, 10, 11 and 12 in the sides. Going on to the second solid, look at this. It has got 1, 2, 3, 4 edges on the sides, 5, 6, 7 and 8 edges at the bottom. Let us now try to understand another category of solids, the non-polyhedrons. From the very word you would have guessed what is a non-polyhedron. Yes, these are not polyhedrons at all. That means they do not have any straight edges at all. Hence, solids that have curved surfaces are called non-polyhedrons. For example, a cylinder, a cone, a sphere are solids which do not have any straight edges. Now look at this cylinder. It has a base and a lateral surface and a top where all the surfaces are curved. Next, look at this cone. It has a base, a lateral surface, both of which are curved surfaces. Moving on to the sphere, what can you see? It has only curved surfaces throughout. There is another way in which we can categorize polyhedrons. That is, the convex polyhedron and the non-convex polyhedrons. let us try and understand what are convex polyhedrons. A polyhedron is said to be convex if its surface does not intersect itself and the line segment joining any 2 points on the points of the polyhedron is contained in the interior or surface. Here are a few examples of convex polyhedrons and the non-convex polyhedrons. Now, let us see what are regular polyhedrons. Regular polyhedrons. A polyhedron is said to be regular if its faces are made up of regular polygons and the same number of faces meet at each vertex. For example, a cube, all of whose faces are squares and the same number of faces, that is 3 faces, meet at each vertex. When I consider another solid like this, here look at this solid. It has regular polygon as its sides, that is triangles on the sides and a square at the bottom. But there are 4 faces meeting at the top, whereas only 3 faces meeting at the bottom vertices. Hence, it is not a regular polyhedron. Moving on to another set of interesting solids, that is the prisms and the pyramids. Prisms. A prism is a special type of polyhedron. It has 2 ends which is of the same shape and size, and these ends are parallel to each other and are separated by parallelograms. Like for example, look at this solid. It has 2 triangles at the ends and the ends are parallel to each other and are separated by parallelograms. This is called a triangular prism. Next, consider a cuboid. Do you think it's a prism? Yes, you are right. Here the ends are squares and they are separated by rectangles. This is called a square prism. A prism is named according to its base. So for example, a prism having triangular base is called a triangular prism. A prism having a square base is called a square prism, and so on. So we can say a prism having a pentagonal base is called a pentagonal prism, and the one having a hexagonal base is called a hexagonal prism. Pyramids. A solid shape with triangular faces meeting at common vertex and having polygon base are called pyramids. Some pyramids have square bases. For example, you would have seen the Egyptian pyramids. Those are examples of square pyramids. Triangular pyramids or the tetrahedrons. If the base of a pyramid is a triangle, then it is called a triangular pyramid. Square pyramid. If the base of a pyramid is square, then it is called a square pyramid. Similarly, a pyramid having a pentagon as the base is called a pentagonal pyramid. 1, 2, 3, 4 and 5. And the one having a hexagon as the base is called a hexagonal pyramid. 1, 2, 3, 4, 5 and 6. Next, moving on to the Euler's formula. Now, let us observe a wonderful relationship between the number of faces, vertices and edges of a polyhedron, which was first observed by the great famous mathematician Euler. For any polyhedron, the Euler's formula states F plus V minus E equal to 2, where F stands for the number of faces, V stands for the number of vertices and E stands for the number of edges. Now let us see if this can be verified by some polyhedrons that we have already discussed. Let us take a cube and try to verify the Euler's formula. For a cube, we know the number of faces are 6, the number of vertices are 8, and the number of edges are 12. And hence, we can verify the Euler's formula for a cube. Similarly, you should be able to verify it for any given polyhedron. Now, before we end this lesson on polyhedrons, let us try to recapitulate what we have discussed so far. First, we have tried to understand the different types of polyhedrons. Second, we have been able to understand and identify the vertices, the faces, and the edges of a given polyhedron. Third, we have discussed and described the pyramids and the prisms. Fourth, we have been able to verify the Euler's formula for different polyhedrons. So I hope you enjoyed this interesting journey through the polyhedrons and would further try to explore more such solids. Thank you and have a nice day.